All right. So I am obviously not here today. It's Friday, and I thought I would just make this nice little video to help you through the piecewise functions as kind of a de facto me being in class. Okay, and then if you guys have any questions, I can take those on Tuesday when we come back. But this will be important for the quiz over the weekend, which we need to do and get done by Sunday night at midnight. So let's not wait to the very last minute to do it. And let's work through our piecewise functions. All right. So piecewise functions, as you saw last year, are functions made of intervals of different functions. Okay, they can be either continuous or discontinuous. So they usually take this form. So you have your y equals, and then it's several different functions, all with different intervals in which for their domain. Okay, so the domains change for each function, and you can have anywhere from 2 functions to several functions as you move through there. Okay, so let's look at an example. Okay, so problem number 1 on your sheet has this lovely little picture of a piecewise function. All right, so we always do these left to right, so we want to write the equation of this. So, okay, so y equals, all right, so then I'm going to do my little squiggle. All right, your giant brace, you can probably do it a lot better than I just did. Okay, so we're going to go left to right. So this is a quadratic, okay? So we have to kind of remember our quadratic equations from last year. Well, I'm given the vertex of my quadratic, and I'm also given 2 intercepts. So you can do this in whatever form you want. So let's just do intercept forms. There might be some a term, x plus 5, and x plus 3. Okay, and then to test for my a value, I'm going to use my vertex point of -4, -1. So -1 equals a times -4 plus 5 times -4 plus 3. And this would give me -1 equals a times 1 times -1. And my a value is just going to be 1. How nice for us. So we just need to multiply this out. So foiling this out would be x squared, plus 8x plus 15. So that is my first function, x squared plus 8x plus 15. Okay, then we separate it by a comma, and now we need to give the domain. So this thing goes from -5, and it's included, so -5 is less than or equal to x, which is less than or equal to, and this function goes all the way until -2. And there is no solid dot here, but I'm going to assume there's a solid dot there because this is also, they're going to have an open dot if it's not included. So if there's no open dot, we're going to assume it's included. So this closes out and it goes, and we're going to include the -2. Okay, and then we just have a horizontal line. Well, a horizontal line we just write as y equals 2. So the y equals is already here. So here we just write 2. All right, so that's 2, and we go 2 from -2. Now it wouldn't be a function if I also included -2, so hence why that is an open circle, is less than x, which is less than, and it goes all the way here to 1. All right, so here's where it kind of gets funky. It doesn't particularly matter which one you include here because they're both at the same point. So I'm going to not include the 1 here, and I'm going to include it on the other one. So on my next function, I'm going to say 1 is less than or equal to x, which looks like there's an arrow on the bottom, which is less than or equal to infinity. So this one keeps going at the end of that. So I know the domain, I just don't know the equation. Well, this is a linear equation. So y equals, and it looks like my slope is -1, so -1x. And so if I kept going, this would have crossed right here at 3, would have been my y-intercept. So sometimes you have to do a little extra work kind of figuring out where that line would have actually been continuing on to, even though it's not included in our function, to get the right equation. So this would be negative 1x plus 3. All right, and there we go. There's our piecewise function. All right. So what we can do is then we can do transformations on these functions just like we've transformed any other function that we've ever done. From last year in doing polynomials or quadratics or exponentials to this year doing our sines and cosines from trig, we can treat it the same way. So here we have our transformation. So here it says y equals f of x minus 4. Well, f of x is my piecewise function. So my f of x was the function from last time. So it was the x squared plus 8x plus 15, and it was the 2, and it was the negative 1x plus 3. All right, so if I subtracted 4, so f of x minus 4, so the minus 4 is outside the x, so that means the y values have been moved down 4. Okay, so that means each of these functions has been shifted down 4. So 2 shifted down 4. This would now be from the domain stays the same. And here's my line until I get to here. My linear expression gets the same, so minus 4. So my 2, that's at negative 2, that's the easiest one. Negative 1x plus 3 minus 4 would give me negative 1x minus 1, because I've now moved it down 4. So it now starts here and goes down like that. Okay, and my quadratic gets moved down 4 as well, so now it's down there. So I have the same formula, still x squared plus 8x, but now it's plus 11 because I have moved it down 4. Actually, that is false. All right, the quadratic gets funky. Okay, so the quadratic we have to remember from vertex form. So I'm actually going to go back here and we got to review our little vertex form. So vertex form, f of x would equal our x, and this vertex was plus 4 squared minus, minus 1. Okay, so here's my vertex. So I am now shifting it down 4. So I'm taking this whole function here and I'm taking 4 away from it. So this now becomes x squared plus, x plus 4 squared. My x value didn't move because I didn't move left or right. However, I did move down 4 more. So this is now going to be way down here at 5. And this would have adjusted our quadratic, which actually does still give me x squared plus 8x plus 11. I don't know why I freaked out on that for a moment. So that would be our new function, okay, written in piecewise function notation. So if we did the same thing with now the x minus 2, so this was all for part A. So now we look at part B, and again, so now I'm doing f of x, f of x minus 2, okay. Okay, so now I'm plugging in that minus 2 for x. So my function would look like x minus 2 squared plus 8 x minus 2 plus 15. Minus 2 on this guy, we have moved it to the left or the right, so with a horizontal line, nothing happens to it. It still stays at 2. Okay. With my other function down here, this becomes negative 1 times x minus 2 plus 3. Okay, so I move everything now to the right 2. So what happens here is I get 2 plus 3. This becomes 5. That's because I have moved this to the right 2. So this now looks like this over here, which is going to put this to go through 5. My 2 is going to extend over, okay, because my domains are all going to shift this function 2. So my open circle will now be here. Okay, this function doesn't change because the line didn't move. However, the domain of where it is moved. Okay, so the domain here is now different. It's been shifted over. And now my quadratic was moved. So instead of being here, it's been moved over 2. So it's now going to be here and come up like this and then circle over like that. Okay. And obviously you guys will probably have a much better picture, and you can actually put this into Desmos and stuff to look at that. And there's directions with how to plug in a piecewise function on Desmos on the back of your guys' sheet. Okay, let's do some stretch changes. So we have 0.5 f of x. So again, let's remember our f of x is, it was x squared plus 8x plus 15. And this was 2. And this was negative 1x plus 3. Okay, so I'm going to multiply the whole thing by a half. So that would mean this whole equation gets multiplied by a half. This whole equation gets multiplied by a half. This whole equation gets multiplied by a half. Okay, which would give us our 1/2 f of x. Again, I'm not putting the domains in. You guys would need to do that. Okay, be 1/2 x squared plus 4x plus 7.5, or 15 halves. The 2 would be 1, and this would be negative 1/2 x plus 3 halves. Okay, I'll leave that one as a fraction because we like fractions a lot better. So what this would look like as we're coming in here, so we're not doing anything to the domain. Okay, nothing is being changed with my actual x terms, but so the domain isn't changing, it's just our range. So now here I would have an open circle here, moving this forward, negative 1/2 x. So now I go down 1 over 2, so it's elongating my, so here would be my fake intercept. It still crosses in here, but it now would go down at a much shallower rate. And then 1/2 x, oh, it will look, it would also be elongated. So we would actually have to factor that out, which is still here. It's just taking a longer time to get up. So it'll actually, the vertex would stay the same. It just widens out like that, but actually it wouldn't be over here. So I'm going to X those out. It'll widen the graph going that way. Okay, so as this moves up towards that point right there. And you can do that by you can play with that by plugging in points and seeing how this is actually playing out. And then f of 2x, just like before, this now will affect what's happening in our domain. So now this would be 2x squared plus 8 times 2x plus 15. Here, again, there's nothing to multiply. There's no x in here. So I am not multiplying anything. This still remains 2, okay? But it's the fact that it quickens the graph, all right? And then this would be negative 2x plus 3, okay? So what happens kind of here is now I get negative 2x plus 3, so my mark is still here, but now my slope is going down 1 over 1. So at this point, here, so basically I'm going to dot this graph this line's coming like this, okay? And then you got the 2. Our 2 is still staying across like this. So it's going to hit here. And this 2 is going to truncate. And then what's going to happen is our quadratic is going to quicken as well. Okay? And you're going to see how that, oh, it's not going to go down that far though. You're going to see how that quickens through there. So again, plug in, play with these points, make it helpful so you guys can see that on the Desmos app. All right, so let's look at one last example here, just graphing one. So here we gave you the equation, then we need to graph it. And again, like it says, type in the transformed equations, play around with it on Desmos so you're actually seeing what's happening when you do each thing. And it's really nice on Desmos to use this g of x, because if you plug things in on Desmos as g of x equals, and then you go through and do the piecewise, in which you can do that is, so on Desmos you would put, absolute value x minus 5, and then the squiggly, and then x less than 6, squiggly, then do the same, then do 3, squiggly, oops, from 5, less than x, less than equal to 1, squiggly, and then negative x plus 5, squiggly, x greater than 2. So once you do all of this in one line, it'll graph the piecewise function for you, and then on the next line you can sit there and just do, oh, I want x of x minus 1, g of x minus 1, and then it'll just graph that for you. You don't actually have to do anything, okay? Or I want g of x plus 2, and then you don't have to retype this in every time, and it just saves you some time and effort. So as you look in here, all right, so let's kind of draw a little grid. Probably should have given myself a grid. Oh well. Here we have x minus 5, but x is less than or equal to 6. So, yeah, less than or equal to 6. So there is 1, 2, 3, 4, 5, 6. And here's 1, 2, 3, 4, 5, 6. Okay, going through. All right, so it looks like here I'm greater than 2, here I'm between 1 and 5, here I'm less than or equal to 6. Okay, and so I'm thinking there is a typo on this. I think this is supposed to be negative 6. Otherwise, this is not a function. Okay, so let's start over here. Greater than 2. All right, we'll just do what it says, and then we'll adjust it as it is. We'll go with it when it says. All right, x, negative x plus 5. All right, 1, 2, 3, 4, 5. Here's my y-intercept. Okay, my slope is down 1 over 1. Then I go down 1 over 1. And here at 2. So you plug in 2, we're going to be at 0.3. And why am I at 0.4? We're at 0.3. Okay, I'm just going to X that one out. There's our 0.3, and we are going to be going then, oops, down in a straight line. This is really hard to draw a straight line in a pen. But you would have a nice straight line going downwards, looking like that. Okay, and then from 1 to 5, yeah, these are supposed to be negatives. Okay, those are supposed to be negatives. All right, from 1 to 5, so x equals 1, I am at 3. Okay, so again, I'm going to actually put a point here at 3. And 1, 2, 3, 4, 5. Here's our point. Oops, that should have been an open circle at 5. And I have a nice horizontal line going that way, so there's 3. And then absolute value of x minus 5 as x is greater than or equal to negative 6. So here's the issue. x minus 5, absolute value, 1, 2, 3, 4, 5. That thing is centered here, okay? And then it shoots up with a slope of 1 all the way this way. So this one is actually just going to help you. You got to just plug in that negative 6. So negative 6 minus 5 is negative 11. Absolute value is going to give us 11. So we're actually going to be way out here. Here's 5, 6, 7, 8, 9, 10. We're going to be actually at negative 6. 1, 2, 3, 4, 5, 6. We're going to be way up here at negative 11. And that's a less than or equal to, and then we will just be shooting up like that. So sometimes you're way up out in space, and it's going to look just like that. So yeah, those were supposed to be negative, so make sure you make that change on the sheet. I'm not sure if I copied that over right. I might have just copied an early draft when I was making this. So there's our last example. So, and then problem 4 on the back is basically just playing with Desmos and making different shapes. And do actually do that. I know I'm not there to enforce it before you start the homework, just because it's going to really help you understand how these things are transformed. Okay, because transformations are going to be a big part of that unit. So hopefully this helps moving forward in how the piecewise functions work. Definitely focus on those domains. All right, and we will then see you back next week on Tuesday or Monday if you are a period 3 kid. All right, have a good weekend.